great. This is a continuation of that story, even though we may not be talking about wind turbine, but the topic is indeed asset health and specifically maintenance and reliability. Okay. My name is Gopal. I have been working with the Pi system and in general at OSIsoft since the mid-90s, and we were a lot smaller then. And through several roles, through software development, through services, sales support, product management, and then recently I took on a role as a solutions architect in our partners and strategic alliances group. And in that role, I get a chance to work with both customers and partners. And among partners are also all these CMMS vendors. I'm talking about IBM Maximo, SAP, Oracle, Infor. These are all maintenance and reliability related items, and these could be one of your enterprise class systems. And Pi is coming at it more from the operation side, and the task is to get the two systems talking to each other. There are a lot of benefits. CBM by far is the largest application I can say in terms of when it goes cross enterprise. Just an asset has two roles, right? Either it is producing, doing something, or it is in maintenance, right? And when it is producing, most of the Pi stuff, SCADA, and all comes into picture. The other role that it has is it may be either waiting to be put into production or it is down for some kind of maintenance, and then the work management system comes in, and then you have to allocate a resource and parts and labor, and Maximo and SAP kind of take care of all that. So how do we work across these business processes between Pi and these work management system is really the topic of this presentation. Assisting me this afternoon will be Keith Pierce, and we do a lot of work together, and we also regularly conduct CBM workshops at customer sites, and we are essentially talking to the SAP team or the Maximo team and just brainstorming and how best to do things. And in this talk, I want to start with our punchline. So these are really the takeaways. If nothing else, we want to make sure you recognize that even though I call it CBM, this acronym CBM, condition-based maintenance, it means several things to different people. Even to the same guy, it may mean different things. On average, if I walk up to a reliability director and ask him, is he doing predictive maintenance? The answer is yes, he is. But what he means by predictive maintenance is not the same as what we think about. He is talking about doing some oil analyses, and he sends out his oil analysis to a third-party resource, and they bring back the dissolved gas analyses or the particle content in his lube oil, and he is using that as a trigger for some maintenance action. That is what he means by predictive maintenance. But when we talk to an OSI guy or somebody in the operations, when we talk about predictive maintenance, we are talking about something math-based or machine learning-based. I'm doing some spectrum analyses on vibration data. Maybe that is what we mean by predictive maintenance. So just be aware that the CBM means different things to different people, and Keith is going to kind of step through the different incarnations of CBM. Also recognize, even though the Pi system, its origin is in SCADA and operations, it has a major role to play in CBM. And I just don't want to just say it for the sake of saying it. We are going to illustrate through customer examples. And in fact, we have installations that have been running for decades now. And it is almost 100% all about bringing operations data and maintenance data together and getting maximum usage out of it. And these are installations who have won awards on reliability, things like that. Now, in general, when we talk about CBM, after the data collection is all done, we need to do some analyses. We are trying to get some insights out of it. So the question is, all the analyses that we do is going to feed this business process, the CBM business process. And when we talk about the CBM business process, the lingo that is used by reliability and the folks in the maintenance field is they talk about usage-based maintenance, because how you use the asset has some relevance to how it is going to get maintained, right? And we all have our experience from just the automobile thing, 3 months or 3,000 miles, you take it for an oil change. So that is really the underlying concept behind it. Okay? So usage-based, and we will also use the word condition-based. Now, when I talk about condition-based there, it really means some kind of an assessment that I'm doing, some analytics, some rate of change, some math thingy that I'm going to do to get to transform this raw data. So that is condition assessment. And of course, the last bucket is predictive, and their predictive is our operations kind of predictive, where I'm talking about some advanced pattern recognition, some machine learning, some tool that I need to use to then trigger some maintenance. Now, we are not just limited to process data. So don't think about just temperatures and pressures and flows. Yes, that is already there. But we can also incorporate all the machine condition indicators. So we are talking about vibration, we are talking about ultrasound, we are talking thermography, oil analyses. All these things can be part and parcel of the condition assessment. And we will talk you through and take you through some of these examples. If there is one takeaway for you from this talk, it is you need to get started now. How many of you, by show of hands, doing anything at all in using Pi data for maintenance and reliability? Show of hands. I see a few, but a lot of the hands are still not up. So we are going to take you through very simple things that you can do to just get started in this, in the CBM thing. And lastly, I should mention we have a CBM lab. So this is a 3-hour lab that is running on day 3 afternoon and day 4. Right now, the lab is, the room size is full, but we always have people dropping out. There's a no-show. So if you are interested and if you can stay back on Thursday afternoon or Friday, let us know. And if there is room, you can attend the lab. Okay. Pardon me? Yeah, Friday afternoon is the same lab being repeated on Friday morning, same content.
Okay. Thanks, Gopal. My name is Keith Pierce. As Gopal mentioned earlier, I'm a technical advisor with OSIsoft. I've been here 9 years, and my background is primarily utilities, and I do a lot of work with CBM, condition monitoring, and all of its derivations. So we're going to throw up some of the acronyms we're going to hear throughout this talk, and primarily the focus when we hear from customers, anything about any one of these sort of acronyms is usually around CBM or general condition monitoring. And we've had, like Gopal mentioned earlier, it's an area, one of the sort of 6 themes that most of Pi customers find of interest. And CBM's been so prominent that we actually prepared a guidebook that'll walk you through some of these terms and definitions through the process, how to use the Pi system, how to integrate with your work management system. A lot of examples on both common kinds of equipment and industry-based examples. And this guidebook's on Pi Square, and we've got a link to it in this deck. To understand some of the things we're going to talk about a little bit better, we're going to just briefly go over some business outcomes for you. When you look at a maintenance budget, and in general, the idea of CBM or condition monitoring, you're trying to lower overall your maintenance budget. So usually there's sort of 2 major categories of funding for that. One's capital dollars. Those dollars are usually used for major overhauls or rebuilds or just equipment replacement. And then there's O&M dollars. And O&M dollars kind of fit into two buckets. One's preventative maintenance, maintenance you do in advance as part of periodic work, like changing oil in your car, for example. And the other is corrective maintenance, when you start to have an issue and you get a flat tire and you have to fix that. That's an example of corrective maintenance. And in these stacks, you want to not only spend less dollars, but spend the dollars more effectively. So that'll lead to improvements in reliability and productivity, things like that. So if you understand these sort of outcomes, it kind of helps with understanding some of the different ways we've divided up CBM and condition monitoring. So for some examples, when we talk to customers, they'll often say, we want to do CBM, and then we have a conversation, and they want to do something like monitor for pump efficiency, or they want to look at differential pressure across the screen so they can change filters more appropriately. Could be something more advanced, like heat exchanger filing kinds of calculations. All that's easily done in AF analytics. And the idea is I want to monitor for this condition, and I want to take some action when this condition occurs. So in general, we just call that condition monitoring. Another one is referred to as incipient failure detection. This is sort of how to adjust your corrective maintenance dollars. So in general, this is a graphic of the PF curve. Reliability folks are probably really familiar with this. What this holds is that an asset at its initial life and normal operation, you're getting full effectiveness out of this asset. And over time, as the asset begins to degrade, the failure mode will start to, the failure of the asset will start and continue over a long time frame. And the earlier you can detect the beginning of this failure, incipient failure, then the more time you have to take action. And in maintenance circles for decades, we've always called this predictive, these sorts of measures, predictive technologies or predictive maintenance. So I do oil analysis, I do motor current signature analysis, I do vibration monitoring. It's usually nothing to do with the operation of the asset, but it has to do with the asset's condition. And based on certain profiles of those diagnostic tests, I can have a better idea of when this asset's going to fail. Some of the more recent statistical kinds of analytic tools, I'll talk about in a second, they also are advertised as being able to detect this. It's a little different in my mind. It's more anomaly detection, but we'll go through that. So another area is this condition assessment. So if your assets that you have, for example, if you're a T&D transmission distribution customer, those assets don't move very often. They don't rotate, nothing like that. So a lot of the CBM techniques that apply to other kinds of assets don't apply to those, and so what they have to fall back on is something like condition assessment. So I take a lot of different factors, could be diagnostic factors, could be age of the asset, criticality, CMPM cost ratios, things like that go into an asset algorithm, condition assessment algorithm that I use to score an asset. This is also really useful in general for other assets if you're doing capital replacement. So if I understand the health of my asset, the criticality of my asset, I can use that score across assets to determine where to do work at. If I have a preventive maintenance schedule and I've got options for when to do what when, the score can help me focus the resources in the right place. Another one Gopal kind of touched on, this is more of the so-called textbook definition of CBM. This is driving preventive maintenance technologies based on condition or usage, as opposed to strictly calendar-based. So if you change oil in your car every 3 months, regardless of how often you drive it, you may be changing it more often than necessary. So the idea here is that I do my preventive maintenance tasks primarily, although this can be used for incipient failure detection as well. But primarily it's used to collapse my preventive maintenance budget into doing those tasks that I need to do when I need to do them, which in general should be fewer tasks. So this involves integration into other technologies like your work management, your SAP PM, your Maximos, Infor, Oracle, Asset Suite, so forth. Another one that's, if you're not in power generation, you may not have heard of this. This is called Advanced Pattern Recognition, APR. It actually came out of aerospace and space industries. But what it does is it looks at a group of signals in regard to an asset or a system, and it's based on historically how these variables have interrelated. It looks and compares in current time how these variables are correlating today. And if they are out by a certain specification, then we can detect this difference and we can alarm on it. This is showing the darker black line is showing the actual value. Sort of the dashed gray line is showing you the expected value based on a historical model. And then if after a certain number of samples where it continues to be outside of the band, then we can alert on that. Another name for this is anomaly detection. So just by itself, it doesn't tell us that there's necessarily a problem. I could have a need for a model update. I could have a different condition than I've ever seen before in my model. I could be operating something differently than normal. Could be other reasons why this is. So in this technique, APR is extremely valuable, used a lot in power generation. But what you want to do here is as soon as this detection comes up of an anomaly, you want to be able to quickly drill into that anomaly and figure out, is this real, or do I need to do something to my model, or do I just need to ignore it? Okay, and Gopal kind of touched on it, but this is a journey, not a destination, this idea of CBM. You could do any or all of these as part of your enterprise. Any or all of these might be correct given the asset itself and the asset's role in your facility or your process. Encourage you to get started now with the data that you have, because we know you can do a lot with this data. You don't necessarily need specialized diagnostics or diagnostic equipment. You don't necessarily need specialized technology. With that, I'm going to turn it back over to Gopal for a minute to go through some use cases.
Thanks, Keith.
Yep.
So let's step through some of the specifics on the analytics. I mentioned this earlier, so usage assessment is one such bucket. The most trivial thing that you can do, the easiest thing you can do, not only can you do that using all your historical data in Pi, just sitting in Excel, data link calls, and you can just back test, because you can tell your asset owner, hey, I'm using this asset only 50% of the time or 25% of the time. Very easy to do. And probably one of the first projects I did on this usage assessment was to just look at historical data and back test whatever they had in mind in terms of deploying usage-based maintenance compared to calendar-based maintenance, right? Because calendar kind of assumes that you're utilizing the asset 100% of the time, and that is not true. You're using it only partially, and that is what the usage assessment lets you look at. Now, run hours is just a generic terminology. It could be the amount of coal that gets crushed by your pulverizer, or the amount of fluid that flows through a pump. Anything that you can use to assess the usage. It doesn't even have to be some indicator that comes from your SCADA. It can just be some proxy. For example, the amperage on the motor can tell you whether the pulverizer is running or not, right? The SCADA itself may not have a status indicator saying it is running or idle, right? So there are other proxies that you can use for usage assessment. Now, condition assessment, it could be either the machine condition. We are talking about machine condition indicators like vibration or thermography, hotspot. Those are all condition assessments that we do, or it can also be a process. For example, the heat exchanger fouling that you want to calculate. There are calculations that you can do, or you can use some proxies for that. For example, in a steam condenser, I can watch the flow on the steam and tell you that it is, if the steam doesn't condense properly, I know it is so because the condenser is fouled, right? I'm not actually using the fouling factor itself, but I'm just going to use the steam flow, the amount of steam that is not condensing, because it will progressively get bad. All the steam that you send through the condenser will just come out. It won't condense properly. So that is an indication. So there are different ways of doing this condition assessment and making it part of your maintenance business process. Now, when it comes to predictive maintenance, it can be just very simple things that you can do. For example, the machine condition indicators like vibration or the bearing temperature. If there is a trend to that indicator, then you can just extrapolate that within reason and have some estimate for what is the remaining useful life on that machine. Okay? And then, of course, Keith mentioned this advanced or the advanced pattern recognition kind of models. These are special purpose models, but proven. You don't even have to do a POC because there are hundreds of these installations. And these have been done and have been working for decades. We are not talking deep learning, TensorFlow, none of those, okay? But proven technologies that you can put to use. And lastly, the last bucket is where all these condition assessment, they all kind of come together, especially if all your assets are similar, then you can, for each asset, for each distribution transformer, you can assign a score based on multiple conditions that you may be doing on it. For example, just the load tap changer, you take the count on that, or the amount of acetylene in the dissolved, in the transformer oil. You find that, and you can assign a score to each of those and come up with an asset score. Okay? So this is a simple display where I'm using run hours and coming up with a screen like this, all done within Pi. And trust me, very easy for you to do. You can do this probably in an afternoon or in a couple of hours. If you still need more help, come to the lab. We will take you through this step by step. And just even without your maintenance or reliability guy trained in Pi, all he needs is a hyperlink to this page, and he will thank you for it. Because today, he does not have any visibility at all on how the asset is getting used, right? So I just take all my rotating assets and just find out how much it is running on a daily basis, 24-hour basis. You can see across the column the multiple ways in which I'm exposing that data. So here's an actual example from San Francisco Public Utilities Commission. They did a study on this. They looked at just 4 pumps, and just based on that, they said, if I extrapolate whatever I'm seeing here over 100 pumps, the savings are on the order of $2 million. So you can find this presentation on our website. Another example is where I'm calculating heat rate. I have the manufacturer specs on it, and I use that, put it alongside Pi data to estimate how well I'm doing on the heat rate. And that is a trigger for maintenance. Okay? This is, again, a presentation from TransCanada. And when we put up these slides, we will include the presentation hyperlinks. Another example from TransCanada here, we are just looking at an expected temperature, and you can see the actual temperature. And as the two things diverge, you know there is some cause for concern, and you need to go do some analyses or do some drill down, right? And what they found there was a partially damaged compressor valve. Now, this is a gas pipeline, so we are talking recipes, the big recipes that compress up to 1,200, 1,600 pounds. Okay. Now, here is the example where I'm talking very simple, extrapolate the trend kind of analytics. If the indicator data is coming into Pi, we have ways to just leverage and extrapolate that trend and then tell you what the remaining useful life is. So the first screen shows you the actual data, and this is over a long period of time. And this is over many, many years, okay? And it seems like the asset suddenly failed in the last 3 months or so. But actually, if you have a condition, if you're monitoring it, you have enough time to say that, yes, I have another month to go, another 6 weeks to go before it actually fails. So that is the example that we walk through, and the analytics that you do is to extrapolate the trend and come up with the remaining useful life on that machine. Another example, again, we are using simple predictive. This is air heater fouling example. And you can see this is just using the filter calculations within Pi. And the green line is the delta P across the filter. And you can see over a period of 450 days, just nice straight trend. And you can extrapolate and say, yes, I now have 8 more weeks. The yellow line, 12 inches of water column, is their threshold. And Pi has all the tools in place, and it will be continuously doing these calculations. Every day, the numbers will change as the things are getting used up. And if you have all these through asset collection for all your exchanges, you have a number. And so it's a first pass indicator for your maintenance and reliability guys. And the last one is the advanced pattern recognition, where there's an estimate made using APR on the bearing temperature, and as the two things diverge, you know that you need to go look at it. The APR has been massively deployed at, this is Australia Gas and Light. It is called AGL Energy now, but they made a presentation last year on deploying this technology. The last example, the fifth bucket that I showed, is where we are talking about a composite asset health score. So all the items on the left-hand side are all kind of pie kind of data, operations data. The things on the right-hand side, the breaker test, the diagnostic data, oil analysis, that is all machine condition indicators. But I'm combining the two to come up with the health score on every distribution transformer that I have. PSE&G is the largest utility in New Jersey, 3 million plus customers, about 300 plus distribution transformers. And what you're seeing there is all the distribution transformers on a web page, right? That is what the planner scheduler is using. And the worst assets automatically bubble up to the top, and I can click on any one of them and get to the details on what the different condition assessments are doing and how the raw score has been converted to a health score. Okay? We have details on this too, and we will step through this more in the lab. With that, back to Keith.
Thank you. So in about 2 or 3 minutes, we're going to show you how we did all of this stuff in Pi. So this is, it's obviously a lot of material to cover, trying to do it really, really fast. We've got a lot of resource material available at the end. So we're trying to show that Pi can be used for pretty much any one of these different areas, and there's value in every one of them. A lot of times it's touted that this new statistical analysis technique is going to save you a lot of money. That PM change at San Francisco Public Utilities is extraordinary, but it's not atypical of when you move PMs from calendar-based to condition-based. So I'm going to go through this fairly quickly for the sake of time. For 38, I guess, and a half years, we've been doing pretty much one thing, which is this: getting data out of critical infrastructure and getting it into a Pi system and maintaining full fidelity of all of these signals over the life of the asset. And we've added to that asset framework, which now I can understand all of the data about the asset in one context, which can be an asset or a system, a subsystem, a component, a control loop, whatever makes best sense to you. And then we can add analytics to that, very sophisticated analytics. And then I can visualize that. Saw the little example of a dashboard of just something simple as run hours. And we'll show you another in a minute. And then I can alert and notify on these events. So I'm detecting events. I might be sending them to CMMS. I might be sending them to a subject matter expert to take some kind of action. I might be sending them to a dashboard to do analysis over time. And then I can take this data and I can push it over into other platforms to maybe do something more advanced, maybe share it with universities to do some research, send it to Power BI, SAP HANA, what have you, integrate it into other sort of platforms. So this is our tool called Pi System Explorer. It's actually the admin tool to kind of show you how we connect this together. Top left there is an asset hierarchy. In our example, it's OSIsoft Power Company. So we have our fleet, and then we have a site, and then we have the unit, and then we go into areas of the plant down to a particular asset. And then we add attributes or mappings of all the underlying data, whether that's Pi tag data, calculation data, other data, to the asset itself. And then we do all this by templates. In templates, we can install these categories, and we can group this information to make it easier to consume and view. This is just, sorry you can't read this, but it's trying to show you, I'll show you a little bit of a blow up in a second, but doing fairly simple analysis. So now I want to detect something like an event frame. I want to create an event frame for something like a high vibration. And I specify the event frame template. The template tells me what data I'm going to collect about this particular instance of this high vibration. And I create the analysis. It's not coding at all. It's fairly simple. It's fairly graphical. I can pull in functions from the side to make it easier to do this. I can use attributes, so my actual high vibration limit can change over time as well. And sometimes, well, I might want to detect the time true, so I don't want to get the very brief high vibration. I want the high vibration to last for a certain amount of time. And sometimes I want to actually collect the data before this actual event happens. So before this component trips, I want to get 5, 10 minutes, whatever the right time of data is, about this system or process. How this looks, again, so this asset hierarchy on the left, and then we have attributes, which is all in AF, which maps to all the data. Then we create some calculation that tells us, detects some event condition that we're looking for. And that comes to us via something like an email. And in the email, I can have links to PyVision. So in one environment, I'm accessing all the raw data. I'm creating a structure to see all the data about the asset. I'm creating a calculation. I'm getting a notification. And in the notification, at the bottom, there's some links to PyVision. When I click on one of those links, I can get something like this, a fairly simple, detailed view of an asset. So now I can see all the data about the asset at the time frame of that event with a single click. And I can drill into that data to look at data about the event. I can pull up any data about the asset at this time frame. I can look at similar events on the left-hand side to compare events. On the right-hand side, there are some comments, so I can build up some intellectual knowledge about this kind of event happens on this kind of an asset. What's the correct course of action? I can create dashboards. This is just showing a widget in PyVision called an events table. So I can surface all of the events that have been detected, that are currently open, that have been open in a recent time period, that are open with these kinds of conditions, and create those dashboards. Another thing I might want to do is look at data over time. So this is the data link report in Excel. I can pick an asset, I can pick a time frame, and I can get summary of diagnostic data, bearing temperatures, vibration, some other summary data for this time period for this asset. Then I could change assets or time periods and see a different asset, same conditions, or a different time frame. I can also see all of the events. So if I create, this is a pump example, if I create events for things like cavitation and high vibration and low flow and so forth, I can now see all that. I can chart it, and I can filter to see different events. And with that, Gopal, you want to just, I know we're already over time. Resources is up.
Yeah, the remaining slides are just resources for you when you get back, and you can take a look at it. But we can have questions. The mic runner.
It's really hard to see. No questions? I think we're already over time. We got the next group coming in.
Any questions? Last call? All right, we will hang around here, so please ask.